Welcome to Termite Machine Works. My name is Keith, and today I have a new project, and this is going to be modifying this Cummins diesel bell housing to bolt up directly to the 4-speed Chevy transmission that this bell housing was on. And before we get into that project there's a couple things I wanted to cover, and here's a view before it leaves the shop here to go down and get fit up on the transom of Vince's boat. And this is the manual transducer positioning tool, and you got the full rotation and the tilt. I've got this pretty tight here so that it doesn't want to drift with current, even though you drift and everything else is pretty much going to be aiming in one direction in the flat. This of the bracket right there should be somewhat like a tiller in that same direction. Only theory. So this will be getting bolted down on the boat, and maybe I'll get a picture of it down there. I didn't do a video on it. I've been jammed. I'm getting unburied now. Mat track job just got interrupted a little bit with some marine shafting that came in, and tomorrow we'll be starting on that. But I'm going to try to get this job done this afternoon and maybe this evening, and then Michael, our customer on this, can get it going. And also he has a Facebook that you can follow along with and see the truck he's working on, and so you'll get to see and follow up and find out how this project goes together after we're done. So before we get into this, I have one more announcement, and I have some new entries, new nominations of worthiness for the toolbox giveaway, and I'm going to be coming up with another video there. I have a couple different things that are sent in. I have some boxes I haven't even opened. I have some projects that I haven't even opened yet. I've just been really floored with work. I have pulled, some of you that follow me on Facebook and know me personally, I have pulled my shoulder out of socket. It's back in. I have minimal strength, but I just add my left arm in there. I was overextending myself, and the nerves pinched, and the bicep muscle pulled apart way out of the socket. So anyway, we have a couple. I just want to hit these names here. Joe Scano is a new nomination. And these, you can go to my blog site, and I've already got pages listed for these. So, and I encourage you to check out my blog site and go through the nominations, because this is going to be part of what's coming up here. This is the last month that I'm going to be accepting nominations. And then we're going to get into the judging, and the judging is going to be taking a group of the nominations and putting them into a final pool, which will be the drawing in December. All right. So it's this is only one step of the way. That's going on. Seth Quarrier and Kinsman, Wally Chatelain. I'm I'm not the best, and least, or last but not least, and there's probably, and I hope to see more. This is Cami Lewis, the very first female nomination in there, and she's got a pretty good write-up here, all right, and some photos. And those of you that have kept up with the blog site, you can see that when a nomination sends more information, I put that up on there. And feel free to create a username, log in, and comment, and even ask questions, or proceed to their sites and their links and things like that, and find out a little bit more. The judges are going to be announced here at the beginning of the month of November, and we'll get into that. But anyhow, the What's in Your Box Toolbox giveaway will be continuing on, and I will have an updated video on it probably as soon as I get in more and nearly finish up on the mat tracks. And I told you that Dakota was going to get snow before we were. So Brian, I'm working as best I can. I have projects that I haven't even been able to get to myself. So anyhow, let me get this cleared off and let's get going on this bell housing job. All right, here we have the Cummins 5.9 liter Cummins diesel bell housing. And this one here is a Chevy SM 465 4-speed. And what we've done, or what we want to do, is we want to create this whole pattern, this diameter, into the face that mates up with the transmission on this bell housing. So this hole here is smaller than this one here, and I'm going to catch you up on what I've already done, and then the video is really how do we go ahead and convert this from this point on. Alright, now I'm going to be pulling these studs out here, and we'll do that in a little bit. I think I just got some double nuts here, and we're going to go ahead and screw a couple nuts on here, and then we're going to see if we can get those undone. Alright, what I did to start this whole thing off was to create a ring to reduce this diameter that will be pressed in here so it will be able to guide the pilot on the transmission itself. And I created that ring here. Now to create this ring, I took a piece of 1/2-inch plate, put it on the plasma cutter, and I cut out an inside and an outside. Now I took a piece of Schedule 80 aluminum pipe, and I went ahead and I tack welded that right to the end of there. Then I turned it inside and outside and faced it, and I parted it off, and then I machined it to thickness so that the part would be round and to the diameter that I can create a press fit, and then I would have matching diameters. So after I broke that loose from here, I went ahead and machined this so that this would be the diameter of this bore here. Now I need to make this whole pattern transfer it into this part here. This is my plan, and I created I just took a piece of manila or stiff paper, and I went ahead and I lightly tapped out a gasket style pattern. Okay, now we're going to create a metal sheet that will have this bore, and we'll be able to slip this down in here, and the metal sheet will be tight to this piece. It really doesn't have to be in line with the rest of this. It's just this whole pattern in reference to 90 or perpendicular to the vertical of the bell housings. Then we will go ahead create our metal cutout, and we'll be able to then come over here, put this in position here without these studs in the way, and align our area for solid cutout bores that I will take and create slugs of aluminum that will represent the beef for the threads to be tapped into, so that we have strong enough holding support for the transmission to the bell housing, just as a stock one supplies here. Now our whole pattern, as soon as we get it laid out, we're going to find out how close our pattern is to this pattern, and part of this might be egged out or whatever. We're not going to concentrate on that. We're going to concentrate on where the holes actually need to be and create the openings, create the bosses, and then we will weld in the suit. If we come into half on a hole or whatever, we're going to be cleaning out rotary burn. We're going to be filling in with some weld. After we have that, all four of the slugs in there, then we will go ahead and set this up on the faceplate, hold this down, and we're going to skim across, make sure that we keep this plane perfectly flat. And then we will actually locate our 4 new holes and drill and tap those at the last part of the procedure here to create the bolt up for this transmission and bell housing that we created. Alright, so first thing is, I'm going to show you how I import this pattern here into the plasma cam. Alright, I'm not going to go in the house and actually show you laying this down, face down on the scanner and how to scan it, but I am going to point out to either leave your screen up or put something black in here, because if you just scan it with the lid down and the white face down, you're gonna have a view that looks like this. Now if you put a black background or leave the cover up, you actually have a more significant difference of color between your holes and your pattern itself. So here I'm going to use this scanned image to import into the plasma cam. Alright, so let's go ahead and we're going to back out of here, and I accidentally knocked everything out of here. Okay, new drawing. Alright, let's import an image, and I got everything all cleared out here so that these are here. There's the white one, and here's the one that I made the difference in the back. Okay, so we're going to go ahead and highlight that one, and we're just going to open. We want to import that. You get the import bitmap image window popping in here, and show image in drawing. We want to see that in the drawing, and convert image to vectors. And we want the convert colors, and we're just going to go black and white, because basically this is the simplest. You can go 16 color standard, 16 gray shades, and then you can get into 256 color or grays as well. Alright, and we're going to leave the resolution at 300, and the width and height and all of that. We're just going to hit next. Alright, next section here, it asks you pick background color. Okay, the background color in this instance, we're going to go ahead and pick the black, because we want the white cutout to be our actual pattern. Do we want it to be solid or outline? And we want to go ahead and solid. We pick the solid. There. Now there's our drawing and our image, and the lines or vectors that it created from there. Now we can go ahead, and that's unhighlighting all the lines, and here's removing the image, and you can click on this and bring your image back, so you can work with an image only on plasma cam as well, and it kind of gives you a benefit here. Now what I'm going to do here is I'm going to go ahead, and I have a nice square here, and of course we're not going to really use the square, but that is the outline, and it actually helps hold the project in the vertical or horizontal straight line on the screen as far as in reference to drawing. Let's go ahead and let's add the image back here, and we're only doing this because we're going to be using it, and we can zoom in on this, and we can see the terry surface and how that line actually did follow that pretty much all the way around. It was a pretty good job of computer imitating there, and you can see that little round dot there. Some of these things are things that you got to eliminate when you are importing images. Alright, now I have it already proven that a 1/2 inch bolt screws into those openings, okay, and I know that these holes are larger, but I clamped this thing down and held this, and these holes are pretty darn close to where they're at. So what I'm going to do is I'm going to go ahead and take and create a circle, which I'm going to pick the circle here, and I'm going to type in 1/2 inch. Alright, now I'm going to place this 1/2 inch by eye right in the center. Alright, now we're going to go ahead and we're going to copy this. We're going to zoom out. We're going to go to each one of these. And here's the next one. And you can zoom in where you want. Now you can see the rough edges. You know, I'm using my center point there to show you that, and those are paper particles or rips or tears into that hole there when I hammered it out. But I'm going to pick the main circle that I see cut out there, and that's where I'm centering my image. Alright, now we're going to go out. We're going to go to the next one. I'm placing one of these at each hole. And I'm centering it sort of 4 away. And I'm picking and choosing exactly where I want that to go. You can, like I said, you can zoom in this wherever as far as you want. Then import is exactly to size. Alright, now we know this inside bore here, we measured it, we've turned the inside of our ring. We've also turned this diameter here, and that is 5 1/8 inch. So we go ahead and we punch our circle again. 5.125, enter, and now we go ahead and we zoom in on this hole here. And we set it down, and then we look around. And overall, I think that's pretty close to being center right there. Now let's go ahead and take and remove our photo image, and we can really get a difference of purple line to green line there. And I think I'm going to be pretty happy with that right there. Now we're going to be able to change this, and you say, well, how do you know that that's going to be exactly? What we're doing is we're getting a real close reference here, and we're going to create our own little shape here to have a piece of material to slip over the ring and against the face, and we're going to transfer punch the final dimensions right from the existing holes into the plate that we make. So we're just trying to get a shape cut out here, and the next step is to go ahead and have center pivot points, and I want to go ahead and hit each one of our areas here and put a center node so that I have a pinpoint to that circle or radius out to the finished OD that I want. And same thing here. Every once in a while, if you're not quite close enough, or you don't hit the buttons in the right sync there, you kind of miss your mark there. And all right, we got each one of those. Now I also want to go ahead and let's put one right in the center here as well. All right, we're going to create a circle here, and we're just going to hit that center so that we know that we're coming somewhat off of that center. Okay, we can come a little bit smaller on these two here. Just because I don't want to exceed my paper size here, all right. Now I want to go ahead and create a vertical line, and I'm just doing this as a quickie here, and there we go. And I'm going to go ahead and move that. The reason why I'm doing this and double checking here is because those two holes aren't exactly in line with each other, and that's what I really want to make sure, that we have this hole pattern square with our part or one edge of the pattern I'm going to make. So I'm going to go ahead and I'm going to shrink this ring here down so I can grab the center point here, and I'm going to just bring this down to where I know that it'll touch there. Okay, so I got at least a straight line there on that side of my pattern. That's in reference to horizontal when I go to put this pattern onto the transmission or bell housing. Alright, now let's just go ahead and make a quick pattern here. Now you can go ahead and you just go line, tangent, tangent point, and we go line, tangent point. No matter where you push this, if you push tangent point, it takes you to the edge. And the same thing here. Go line, tangent, and it doesn't matter where you, well, okay. There again, we're getting too hurry there. There we go. Alright. Alright, now we got a pretty good pattern right there. Let's go ahead and trim what we don't really need on here. And one is we don't really need the outside box. We can go ahead and trim this line, that inner circle, that part. Okay, hit join. Okay, now that straight line, we have a couple overlaps or double lines right here, and there's our bubble. Okay, now we can go ahead and take our scissors and we just trim off that outside one there. And let's scoot down here, and I'm pretty sure down at the other end it's going to be the same thing. Zoom in here, and we knock off that one there. And now we can close that entire loop. There we go. All right, now let's get rid of a few of our other things there. That squiggly line we don't need, and we don't need that. We don't need that. That squiggly one. That one. Anytime you got some scatter like that, you can get rid of it if you want through your images, and you can just circle them. And so I'm happy with that right there. We're going to keep that as our pattern, and we're going to go ahead and we're going to marry that. And now that we can click on any part of it, now we can highlight it. All right, and we know that this is our square or horizontal line. And now we can go ahead and we can create a cut line off of this if we want right now, or we can lay it where we need to and then make the cut line in reference to the plate. And sometimes I change that around, but I just go ahead and we'll create a cut line right here, automatically convert holes, yes. Okay, and right now everything is ready to cut. We can marry that, and now we're going to go find a piece of material, and we just want some thin gauge aluminum to go ahead and make our cutout. And we're going to go ahead and cut out a dummy pattern, and we're going to slip it on. We're going to hold it in place, and we're going to take a look at it and see if it's good enough to go ahead and transfer punch our holes in our template. Alright, before we actually get this cut, and we have a piece of plate on the bridge, or on the plasma cam, almost said Bridgeport. Anyway, and we have our drawing here. Now we're going to go ahead and change a little bit because we want to transfer punch from the original holes right onto this aluminum. So we're going to go ahead and we're going to break loose our connection here, and we're going to go ahead and we're going to delete the cut paths from these 4 holes here, and we're going to leave that center one there. Now this is what I was saying that I might want to change an outside. This pierce actually starts here, and then it would be going around here and coming around, and as it comes around here, it's starting to release itself from the rest of the plate. And then it has a very narrow band right here, and there's a chance that a lot of things can be moving around. I like to have the last line of cut on my part still holding the major piece of plate on the table, and it holds it still, and you get more of a true cut on your outside. So I want to go ahead and eliminate this outside, go ahead and convert this back to a cut. And I'm going to put it on this corner here because it's going to come around here, and the last cut will be across the top here. Alright, and I like to put it on the corner here so you can ferret in, and I don't need holes done because I've already got that done. All right, and now we go ahead and we'll marry that right there. All right, and we highlight it and we look at the cut preview, and it starts in the center, goes out to the line, comes around the outside, boom. Okay, all right, so let's go ahead and we're going to get ready to go ahead and cut that. All right, here we go. Okay, contacted that metal and just signaled it. And it paused it. Okay, we've got our fans and stuff. A little warm, not bad. Now, this diameter, we cut this exact size. I don't expect this thing to actually fit in here, but almost half of this does slip through there in a couple different directions here. We're going to go ahead and take a rotary burr. We're just going to skim this real quick so that we get a good slide in here. Now you say, why didn't you cut the holes in here? And I want to make sure we have the ultimate precision to actually create our transfer onto this here. So we're just going to go ahead and get this to where that fits in there snug. We could even put a couple tacks here just so that it doesn't move around in rotation or anything else like that. I don't think we need to be that close. As long as I got a good snug fit on here, it'll hold that location. And then we're going to go ahead and we're going to do our transferring on our holes, and then we'll have a pattern that we'll be able to take the coaxial indicator and actually locate our holes on the bell housing one at a time. Yeah, it's almost stuck there now. Alright, we went ahead and picked up our pneumatic tool here, which we're probably going to be replacing this. We've already pulled this apart, made vanes and everything else, but this thing is, I think this is nearly 20 years old. And we got a cross pin going in here and it kind of leaks air, but it's still working fine. And just rambling on, I was pointing that out. You can hear the air leak. Alright. I'm just going around, I'm just gently, I want to just kind of massage this up to size. This is tight, and there probably is just a little bit of idiosyncrasy right here in that circle where it met each other. As it was going around, it was probably heating up the plate and moving a little bit. Holding it down on the bottom in a continuous motion around and using the cross hatch, it doesn't grab and it doesn't seem to make grooves in there. And I can really see the light reflecting on here, and it really helps. Alright, more or less in the rotation and the pressure I'm putting in the direction is like a conventional mill. And instead of climb milling, I'm doing a conventional mill position. I'm holding this pretty well square to my part, so I can kind of get the feel that I am square to the hole. There was a little bit of angle from the speed of the cut. Even though you can cut this material at 220 inches a minute, I was cutting it at about 100 because I want more of a straight curved surface on the outside. So that's why I held it to there. There was no other reason. Alright, we got a little bit there. Let's see how we do. We can look down at it a little bit, and I mean, it's almost there. Almost wants to stick. we're not going to concentrate in any one area, we're just going to go around again. I stand it up on the corner there so I can kind of get between where I was concentrating with the same feel. Alright, try that again. There we go. Alright, close enough for me. Alright, and I believe it goes that way right there. And this is our straight line that's going to be our square. And we have a bell housing line right here, a seam, and we can put a straight scribe line right here in relationship to being square. I'm going to go get the square so that I can eyeball that line. I'm going to put a little mark there and a little mark here, and then I'll be able to scribe straight across right here, and that'll kind of keep a visual line with there. I do see a split line there too. We'll see how that matches up when we move it over there. Okay. Nice. Alright. Of course we got to remove those studs now. Alright. I'm going to go get a scribe and a square. Alright, I put this in here and I got my square set so that I got clearance here so I can see off of this surface right here that I'm square in line here. All the way down, that split line is looking really good. I like that. And I'm going to go ahead and I'm going to mark that right there. And I'm going to mark it right here. Now this line on this side here is not exactly square, so I don't want to follow that slight angle there. So I'm going to go with this bottom one. I know that this is the square line that I set up with the with the pattern that I had. Alright, so now I can go ahead and pop this out. I made this tight. This has got a lot of corrosion and gunk around here, so I left it tight, and this will pop off. Now we'll go ahead. I'm just coming over this, making sure that we have a straight line and that comes out matching. I like that. Alright, now we're going to go ahead and we're going to get that slipped on there. And I think our next step is to go ahead and pull these two studs out of here. And I got 2 1/2-inch wrenches here. I didn't even have to work real hard on that one. But they're not all dried out and rusted up either, so kind of nice when you're working on diesel sometimes when they got moderate leaking. Everything stays kind of fresh. Good. I'm glad we didn't have any rough, hard problems pulling these out. Alright, I don't feel any deep burrs or anything. Maybe one little place right there will stand. And we're going to go ahead and get this pressed in here so that we can then take our jig and go straight on over here. And make sure that this thing is upright. Alright, we took a stainless steel wire brush and we kind of hit the space lightly in here and a little bit around in here. We're going to really detail in our areas of welding that, you know, this has got some grunge all over here. I don't have a solvent tank or any other way to steam clean it or get any of the other stuff off of there, and without putting any of the other chemicals on there. Now this almost like wants to start right in here, and I think I'm going to put that surface out. Half a dozen the other, doesn't matter. Alright, now, nice flat table here, no highs or lows or anything else on there. And I'm going to set that on there like that. And I'm just going to see how easy this is. It's a pretty small ring. Some things you can go put in a press, and sometimes you get so much bulk in a press that you're not really going to have the finesse that you need to put it right in there. Pulling some wire wheels out of my stomach there. Alright, and we want that to be nice and flush right there. And actually it looks like just a little too far there. And this is just this doesn't spin or anything else, it's just a location here. There we go. Alright. Hold it on both at the same time. Alright, we're looking good there now. And we got our ring pressed in there, so we got the same diameter as the original. And now we can go ahead and set up our pattern. And we can rotate this in the right direction also.